Hi, this is Poongodai, Assistant Professor in CAI Department, Madanapalli Institute of Technology and Science. Welcome to Sorting Technique session, Selection Sort. So, in this presentation, we will discuss about the introduction of selection sort, working of selection sort, algorithm, its implementation, analysis and complexity, and summarize it. Selection sort, it is a simple sorting technique and it's easy to implement. The entire list will be taken and it is considered as unsorted list. We repeatedly find the smallest element from the unsorted portion of the list and we swap it with the first element of the unsorted portion. And this process is repeated until entire list is sorted. We sort the small list of element using selection sort. Generally, we will not use it for a longer list. Let's see the working of selection sort. There are 7 elements in the list: 4, 8, 28, 2, 13, 3 and 9. So initially the entire list is considered as unsorted list. It goes with several passes to get sorted. In the first pass, we find the smallest element. So in that entire unsorted list, we have to find the smallest element. So here you can see here in this list the smallest element is 2 and the first element of the unsorted list is 4. So and 2 and 4 should be swapped in the first pass. You can see here 4 is the first element of unsorted list and 2 is the smallest element in the entire list. So it has to be swapped. 2 becomes the sorted and remaining elements will be the unsorted list. In the next pass, the first element is the sorted and the remaining elements are unsorted. We have to find the smallest element of this unsorted list. So it is 3 and the first element of the unsorted list is 8. So 3 and 8 should be swapped. We see 2 and 3 are in the sorted and remaining elements are unsorted. So in the unsorted list, in the next pass, that is pass 3, the smallest element of the unsorted list is 4 and the first element of the unsorted list is 28. 28 and 4 should be swapped. Becomes a sorted list, remaining list is unsorted. So in next pass, that is pass 4, the smallest element is 8. The first element of the unsorted list is 28. So 28 and 8 has to be swapped. So that now in the next pass, in the pass 4, 8 will be coming into the sorted list. So 2, 3, 4, 8 is the sorted list. Remaining elements are unsorted. Next pass, pass 5. You can see that the smallest element of unsorted list is 9. The first element of unsorted list is 13. It should be swapped. So 9 occupies the first position of unsorted list and 13 goes to the that position. Index number 6. Now, so at the end of pass 5, the first 5 elements are sorted, remaining 2 elements unsorted. We go for the next pass. Pass 6. The smallest element, it is 13. The smallest element is 13 and 13 and 28 should be swapped. So here at the end of the pass 6, we can observe that all the elements are sorted. So we have 7 elements in the list. So total number of pass required is only 6. So if you have n elements, only n minus 1 pass required to sort the entire elements. So for n elements, n minus 1 pass only required. Let's go to the algorithm. The first step is start the process. Read the number of elements to be sorted. Third step, read all the elements of the list. Fourth step, the step 5 and 6 should be repeated for n minus 1 times. So why n minus 1 time? Because number of pass required is n minus 1. In each and every step, in the every pass, we have to find the smallest element of unsorted portion and swap it with the first element of unsorted portion. So this step is repeated for n minus 1 times and we get the sorted sequence. Step number 7, print the sorted sequence, stop the process. Let's see the implementation. In the main program, first we read the size of the array, nothing but number of elements to be sorted. Then we call the read function to read all the array elements. Then selection sort function is called to sort the entire list. We call the display function to display the sorted sequence. So this is the read function, read all the array elements. It starts from 0 and up to n minus 1. I less than n means so n minus 1. It read all the n elements. Similarly, in display function, we display the array elements after sorting. Now we go to the selection sort. So in the selection sort, we sort the elements. Okay, so you can see that in the selection sort, the process is repeated for n minus 1 time. Since we have n minus 1 passes, we have to repeat it for n minus 1 time. So in each and every pass, we find the smallest element and we swap it with the first element of the list. So when I is equal to 0, the first element of the list is in the location 0. So that's why we use the same variable I. We can see here I equal to 0 means in the first pass, the index number of the first element is 0. So the value I. In the second pass, if you take the first element of unsorted list will be in I equal to 1. So when you are calling that second pass, we are swapping with the second element here. So it is repeated again in every pass. Finding the minimum element, that swapping with first element of the array. Unsorted list. So we find the process is repeated for n minus 1 time. First, we find the smallest element. Initially, the first element is taken as the small, minimum one. Its index is stored in the portion min underscore int. Then, we we compare this minimum element, first element with the remaining elements. So, the process is repeated to find the smallest element in the first pass. We have to compare that minimum value with the remaining n minus 1 element. So that's why j varies from I plus 1 to n. So if that minimum value is greater than a of j, then we have to replace that minimum element. When you are changing the minimum element, you have to store that index portion j also into the min underscore int variable. So this particular process, step from here to here, So this entire thing, it finds the smallest element. Once we find the smallest element, we can see that it is replaced with, that smallest element has to be replaced with the first element of unsorted list. So the first element of unsorted list is in the location I. Actually, I refers to first element of unsorted portion. Next, so once we find the smallest element, we swap it with the first element. So this is what done here in the swap. So with the example, it is shown here. So entire list, the first portion of the first element of the list, it is in the index number 0. That's why I is equal to 0 here, and we are passing minimum first element as I of I. The first element 4, it is compared with the remaining elements. No, this is what we are doing here. First element 4, we are storing it into the min variable. So min is equal to initially 4, and this 4 is compared with remaining all the elements 8, 28, 2, 13, 3 and 9. So it is compared with all the elements. Once we find the minimum element, that is, so you can see here the minimum smallest element in the list is 2. Once we found the 2 and 4 are swapped. 2 occupies the position number 0. 0 is in which variable? I. And 4, it is placed in the index position of 2. The index position of 2, it is nothing but min underscore int variable. So these two elements are swapped. Likewise, it is done in every pass. And once here I want to remind once there are n minus 1 pass. Once n minus 1 pass is completed, an entire sequence is sorted. One small improvement in the insertion selection sort algorithm. One small improvement in the selection sort algorithm. Here we can see that in the unsorted list, the index number of smallest element is, see here, 0, 1, 2, 3. The index number of smallest element 2 is 3 here. The index number of first element of unsorted list is 0. Both are different. So this is 0 and this is 3. You can see here the index number of 4 is 0 and index number of 2 is 3. Both are different. When both are different, the whatever the program algorithm we have discussed, that works. But in the this case, you can see here, in this list, the smallest element is 4. So the smallest element is 4. Its index position is 0. And the first element of unsorted list also is 0. Both are same. When both are same, no need to swap. No need to swap, no? Because both are same. And it is already in the correct position. You can see here, the 4 is in the same position, it is sorted list. Remaining are unsorted. So, this improvement can be done in the implementation. So, here we can see that the min underscore int, it is the index number of the smallest element. I is the index number of the first element of unsorted list. If both are not same, then only we do swap. Otherwise, no need to do swap. It is in that position only. Analysis of selection sort. So here, The loop is repeated for n minus 1 times. In pass 1, the first element is sorted. In pass 2, next 2 elements will be in the sorted, it will come into the sorted portion. So when in the pass 1, we take the first element as the smallest element and we will do comparison with remaining elements. So if there are, now I have 7 elements in the list. The first element is compared with 6 elements to find the smallest. So if there are n element, the first element will be compared with the remaining n minus 1 element to find the smallest element. So in the first pass, the number of comparison required is n minus 1. Second pass, we have to take the second element. You can see here 8 is the second element. This element, it will be compared with the remaining elements to find the smallest element. So 8 is compared with all the other elements and we found that 3 is the smallest element. And 3 comes into the sorted portion here. So in the second pass, the element, to find the smallest element, we have to do n minus 2 comparison. Similarly, in the third pass, n minus 3 comparison. Fourth pass, n minus 4 comparison. Likewise, it continues. So at the end of, so only n minus 1 pass is required. So at the end of the pass, only one comparison we do. So when we check everything totally, we need n square a comparison. Number of comparison required for selection sort is n square. Time complexity. There are three time complexity: worst case time complexity, best case time complexity, average case time complexity. The worst case time complexity is the elements in the list, if it is sorted in almost reverse order, then it is the worst case. Each and every element of the list should be relocated because it is in reverse order. It should be relocated. That is the worst case time complexity. So many number of comparison we do. Similarly, in best case time complexity, if the list is already almost sorted, all the elements are already sorted, then we say it as a best case. Very less number of data movement swapping will be done. That's why we call it as the best case. Next, in the average case time complexity, list is the elements in the list is partially sorted. So in all the three cases, worst case, best case and average case, the time complexity of selection sort is big of n square. Let's summarize the today's session. We understood that the smallest, the loop in that algorithm, in the selection sort algorithm, is repeated for n minus 1 times. That's why the required number of passes is n minus 1. And each and every pass, we find the smallest element from the unsorted list and we swap it with the first element of the unsorted list. And it is continued for n minus 1 time and the entire list becomes sorted. So we this selection sort, it is particularly specifically used to sort the smaller list. We will not use it for the more number of elements, to sort more number of elements. The time complexity, it is big of n square because the number of comparison we found that it is n square. And when the cost of swapping is not a matter, then we go for the selection sort. I thank my department for giving me this chance to deliver the session on selection sort. Thank you everyone.